Hello guys, welcome to the channel. This video is episode 4 of a series called A Young Person's Guide to Calculus, and this is a series that aims to teach different um, equations and techniques that cover different areas of calculus. So today's video is on product rule, and we're going to be covering a few things. We're going to be covering its application in calculus, so when do you need to use it, and how to recognize that you need to use it, what is the equation, uh, a nice little proof so you understand why the equation works, and then some practice questions to get familiar with it. Cool. So product rule. So product rule is defined as a formula to find the derivative of two multiplied functions. So that is if we have y is equal to fx times gx. And this is in a case where we know how to differentiate fx and we know how to differentiate gx, but when they're multiplied together, it's a bit complicated or we don't quite know what to do. So here's a few examples. We have y is equal to cos x e to the x, where fx is cos x and gx is e to the x. And another example, x to the 5 natural log of x, where fx is equal to x to the 5 and gx is equal to the natural log of x. And what I would say is identifying the functions. And I mean, in these cases, maybe it seems elementary, but it's a very important process because the math will take care of itself. But the main thing and the most important thing to start strong with any question is to pick the right functions so that we split everything up as easily as possible to do. Cool. So the equation is if we have y is equal to fx gx, then dy dx is f prime x gx plus g prime x fx. And I just wanted to also say that sometimes in a textbook, or you might see online, that we just say y is equal to uv, where u and v are functions, and then you say dy dx is equal to u prime v plus v prime u. And here I just have a quick thing to say that sometimes we let a letter represent a function. I know maybe before or maybe we're used to saying a letter represents a variable, but in this case, a letter will represent a function. And we can, when we find the derivative of that function, we just slap a prime in front. Cool. And I have a quick example. So taking the example from the last slide, x to the 5 natural log of x. If u is equal to x to the 5, v is equal to the natural log of x, u prime is equal to 5x to the 4, and v prime is equal to 1 over x, and then just saying u prime v plus v prime u, you get this. And we can clearly see u prime here, 5x to the 4, v, which is natural log of x, and then v prime 1 over x, and then u is x to the 5, and it simplifies to produce that. And there you go. So that's how it works. In terms of finding a proof, just a quick heads up, you don't need to know this proof for your A levels, but it's always nice to know why things work. And I think when you know why something works, it gives you a lot more flexibility or gives a lot of leeway. It's easier to spot mistakes and stuff. So here's a nice little proof. So if we're saying y is equal to fx gx, then dy dx will equal to the derivative of fx times gx, which makes sense. And then what we can do is we can apply first principles, just like so. And if you're not familiar with first principles, I touched on it or I explain it in the first video of this series. So please do check that because I'm going to assume you understand what's going on. So we have h tending towards 0 and then fx plus h, da 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 da. That's standard. And then the denominator was simplified to just h. And what I've done on the numerators is this nice little trick of adding 0 creatively. So if I subtract fx plus h gx and add fx plus h gx, just like so. This is to try and set things up so that we can split it up into two different limits, where we have fx plus h gx plus h minus fx plus h gx over h, and then fx plus h gx minus fx gx. And this is starting to look more promising, and you can factor out on the left here, you can factor out fx plus h, and on the right you can factor out gx, just like so. And now it kind of tidies up, because if we apply our limits as h tends to a 0, fx plus h is going to equal fx, because we want h to be as small as possible. And then this is, with first principles, is just the equation of finding the derivative of something. So this will equal g prime x. And then here gx is fine. There's no h's to deal with. And here this is the formula for finding f prime x. So that will all simplify to this, which we can then tidy up like that. And you get fx g prime x plus gx f prime x. And that's how the formula works. Cool. I have a few practice questions here. I have a bonus question, and the bonus question I've prepared a hint. So I'm just going to pause for a moment for anyone who wants to try these questions and without the hint as well. Cool. So in terms of the hint, it's maybe you can recognize that there's 3 functions here instead of 2. But what you can say is if y is equal to fx, gx, hx, you can say ix is equal to gx, hx, and then you can say y is equal to fx, ix. So that's the hint. So if you want to try question 5, you can give that a go. But let's dive into the answers. Cool. So question 1, which first thing is identify what our functions are. So v is equal to x squared, u is equal to ax squared plus 3 to the 5. And I deliberately lay it out like a grid. I mean, you don't have to do it like me, but I don't know. I find that to be easy, so feel free to copy that if you want. And then you can just say, taking the derivative, v is equal to 2x, and then u prime x, if you apply chain rule, you will get here, just like so. And then it's just about applying the formula. So v prime u plus u prime v. Yeah, should. Well, I did u prime v plus v prime u. It's the same thing. And then that should simplify like so, because x squared times x is x cubed. And there you go. And that's the first question done. Looking at the second question, again, it's just about saying the variables out. Oh, sorry. I also added here the answer in factorized form. And I did that just because there's this ax squared plus 3 to the 4. And there might be a few people who wrote it in a factorized form. So that's just for you. Looking at question 2, v is equal to this function, 2.5x cubed minus 5x squared plus x minus 10. And then we differentiate. V prime is 7.5x squared minus 10x plus 1. And u is equal to the natural log of x. And u prime is equal to 1 over x. And then if we just apply the formula, you just get this. And there's no simplifying that you can really do. I should have brackets around here. Sorry for that. But just imagine there's brackets around there. There's not really much simplifying you can do, I'd say. So there you go. That's that question. Question 3. You can say u is equal to 3x, e to the 3x squared. V is equal to the natural log of x. U prime is equal to 6x e to the 3x squared. And this should be v prime, sorry. V prime is equal to 1 over x. And then if we apply the formula, you get this. And not much simplifying can be done. So that's kind of just there. Done. Question 4. We can then say u is equal to 1 plus 2x to the 5. V is equal to the natural log of x squared. U prime is equal to 10, 1 plus 2x to the 4. And then v prime is just 2 over x, natural log of x, using chain rule. And then if you just apply the formula, you get this. And I didn't leave it in factored form, but you can factorize out natural log of x and 1 plus 2x to the 5 if you wish. 1 plus 2x to the 4 if you wish. That's an option. And question 5, the bonus question. So I start off by adding extra brackets around 1 plus 7x to the 4 natural log of x. And that's just my way of saying that those are going to be my 2 different functions. So u is equal to e to the x. V is equal to 1 plus 7 x to the 4 natural log of x. U prime is equal to e to the x. And then I can't just work out v prime straight away. I need to apply product rule again. So if I say s is equal to 1 plus 7x to the 4, t is equal to the natural log of x. And then s prime will equal this, t prime this, and then I can apply the formula to get v prime is this. And now I have all the ingredients I need to apply the formula. So then u v prime plus v u prime will produce this here. And then you can factor out e to the x if you wish, and get this as your answer. So there you go. I hope that was clear. And that's all I've got for today. So I really hope you enjoyed the video. I hope you learned something or got some good revision done. And I look forward to seeing you guys next time.